cutaway, you'll hear the DDO call out the final countdown. Enjoy the launch.
Top à 0-20 secondes. Lagage du mât VKM, allumage triétage, à tous de DDO. Attention au décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top décollage. Les paramètres bord sont normaux. Bon fonctionnement des moteurs du premier et deuxième étage. Stabilisation du lanceur sur les 3 axes.
Well, fine shots. Always impressive no matter how many times you see Soyuz powering into the sky. 309 tons at liftoff. That's less than half the mass of Ariane 5. The boosters are the first stage. The boosters on the central core or second stage are burning now,
Les paramètres bord sont conformes à l'attendu.
As the DDO says, all is well on board. The boosters weigh 45 tons each at liftoff. Total mass of the first stage, 178 tons. Their engines running on liquid oxygen and kerosene. The same propellants used in each of the 3 lower stages.
Les paramètres propulsifs sont conformes à l'attendu.
The second, or the core stage, similar to the boosters, its ignition occurred on the launch pad. As you saw, the stage will burn for 4 minutes. Remember, Soyuz weighed 309 tons at liftoff after separation of her boosters, which you may be able to see by with the naked eye, but there's the onboard camera showing what it looks like.
Séparation des 4 propulseurs.
At separation of her boosters, she's down to 135 tons. So in less than 2 minutes, she loses more than half her weight. On the bottom of your screen on the left, our altitude, on the right, our speed. These figures coming in from the downrange stations. Galileo in yellow on the screen, on the left just disappearing. That's the local station here in Kourou. The data are received by the Russian teams in the launch center, then confirmed before being broadcast. Next up is jettison of the fairing. That's in about 20 seconds. Fairing measures 4 meters in diameter, stands about 11 meters tall. We can get rid of it now in 17 seconds because we no longer need the protection it gives the satellites during their ride through the Earth's atmosphere. At 100 kilometers up, we are out of the dense layers of the atmosphere. There's no more friction, no more heating, which can disturb anything to disturb the satellites. And there you see the fairing jettison. There's another half, which is out of camera range on the port side of the vehicle. This powered phase of Soyuz's first 3 stages will last about 9 minutes. Then the upper composite, called the frigate, that's the upper stage, with the satellites, will be separated. It takes over and does the rest of the work, completing the mission. Europe's space effort is a 3-way affair. Arianespace, marketing and operating the launch services, and the Ariane program. The European Space Agency funding new programs. And the French Space Agency CNES overseeing separated. It takes over and does the rest of the work, completing the mission. Europe's space effort is a 3-way affair. Arianespace, marketing and operating the launch services, and the Ariane program. the European Space Agency funding new programs, and the French Space Agency CNES overseeing coordination of all space-based operations. Marianne Claire, you heard her here just at the beginning of the broadcast, new director of the space base since a month, roughly, and also the first woman to hold the role.
Confirmation de la séparation des deux demi-coiffes.
The CNES site here, chosen in 1964 because of many advantages, not least among them a large opening on the water. We have 50 kilometers of coastline, which makes possible flying both north and east, north for sun-synchronous orbits like tonight, east for geostationary orbits. Coming up on separation of the second stage. There you see what it looks like on the animation and what it looks like on the onboard camera. 186 kilometers up. And we will have ignition of
Allumage bloc
the
I.
third stage. The DDU has just called that out. One
Séparation bloc
unusual
A et
aspect
inspection.
of the Soyuz, whereas with Ariane, for example, we separate the lower stage before igniting the upper stage, Soyuz does the opposite. The third
Langage
stage
section arrière confirmé.
is actually ignited 2 seconds before separation of the second stage. The reason being, the lower part of the third stage, called the skirt, is used to channel the flux of this
Fonctionnement
third
normal
stage
du
motor
moteur, troisième
ignition
étage.
down toward the stage below, where it rebounds, giving an added thrust, assisting separation. The third stage skirt is then separated 10 seconds later, and during those 10 seconds, Soyuz climbs 4 kilometers. In an older version of Soyuz, without the frigate upper stage, it's the third stage, which put the satellites into its initial Earth orbit. Our next film, and the first on our passengers, coming up on Cosmos SkyMed second generation.
Hi, I'm Véronique Loisel, and I am the Program Director for Cosmos SkyMed second generation at Arianespace. My work mainly consists in interfacing with our customer for all subjects linked to technical matters, but also contractual, communication, financial, insurance, and legal aspects. Our job is to respond at best at our customers' requests. As for Cosmos SkyMed second generation, the 2,205 kilogram main satellite was manufactured by Thales Arianespace in Italy for the benefit of the Italian Space Agency and the Italian Ministry of Defense. It is a dual system, civil and military, designed to address the requirements of both commercial and government customers, as well as the scientific community. Cosmos SkyMed second generation will be part of a constellation of 2 satellites, which aims at providing an enhanced quality of the imaging services to the end customers with respect to the current CSG constellation. Thales Arianespace is a very important customer and partner for Arianespace. Indeed, Cosmos SkyMed second generation represents the 167th satellite manufactured by the company and to be launched by Arianespace. It will be also the 4th satellite to be launched for the Italian Space Agency and the 9th for Italy, comprising ASI, Italian MOD, and Telespazio.
You may have noticed that since the start of the mission, events are announced by the DDA with maybe a slight 1-2 second delay with the pictures you see on the animation. This is quite normal, nothing to be alarmed about. The information, that's telemetry and radar, coming into the ground stations, then sent by them here to Jupiter, have to be first confirmed by our Russian teams in Moscow. Then they come to French Guiana at the CVI, which is the Quick Look Telemetry Center, which relays them to the DDO here. So at certain moments there might be a short time lapse, nothing abnormal about that. We will be going up to the CVI for a visit later in the broadcast. The Soyuz we're using today, it's the most recent version, the Soyuz 2. Originally, you might recall, Soyuz was a missile called the R-7, the world's first intercontinental ballistic missile, ICBM, developed in 1953 by Sergei Korolev, who was the father of the Soviet space program. The Soviet R-series was modeled on the German V-2. On October 4th, 1957, R-7 put in orbit Sputnik, you will recall. There's the separation of the third stage. See what that looks like. And with that, we have come to the end of the first part of the powered flight phase. We're now awaiting confirmation of the first frigate burn. Saint-Hubert at the top of your screen. That's our next downrange tracking station. It's
Extinction du troisième étage et séparation du troisième étage.
We're waiting for confirmation of the first frigate burn. There will be 7, remember. Some will take place during the breaks, so we won't see them. We're going to cut away twice at 2 moments during the broadcast. We need 7 burns because we're launching 5 satellites, and although all are headed toward a sun-synchronous orbit, each has to go into its own orbit, of course, and its own altitude. And an interesting mix of satellites for this mission, multiple mission tonight. Cosmos SkyMed, Earth observation, the scientific mission CHEOPS for the European Space Agency, and then in the final part of the broadcast, 3 CubeSats, small ones, OPS, SAT, ISAT, and ANGELS. We'll be describing each in turn. There you see, right on time, the first ignition of the frigate burns coming at 470 kilometers up, roughly. Our speed, 6.2 kilometers. This first burn will last 11 minutes. The second burn will take place at +1 hour into the mission, and the third, 51 minutes later. The frigate upper stage, produced by NPO Lavochkin, prime contractors. Mass at liftoff, 6.3 tons, carries almost as much in fuel, 5.3 tons. The frigate stands 1.5 meters tall. Frigate is an autonomous, flexible upper stage, relatively recent addition, qualified in 2000. It has been designed to operate as an orbiter and thus extends the capability of the Soyuz, giving her access to all orbits, low Earth orbit, sun-synchronous like tonight, medium Earth orbit, GTO, GEO, and escape orbits. It's independent from the lower 3 stages, since it has its own tracking telemetry systems, navigation, and guidance. Our second film on Cosmos SkyMed, up next.
The Cosmos SkyMed system consists of a constellation of 4 identical satellites equipped with a high-resolution SAR, synthetic aperture radar, operating in X-bands. It is a dual civil and defense system designed to address the requirement of both commercial and government customers, as well as the scientific community. Cosmos SkyMed allows global coverage of the planet, operating in all weather conditions and lightning, and provides geolocalized images with extreme accuracy. The Cosmos SkyMed system is a flagship of Italian technology in the world. It is the only constellation of this type currently existing in the global level. It is founded by the Italian Space Agency and the Ministry of Defense and the Ministry of Education, University and Research. The first and second generation of Cosmos system is a result and expression of the best skill of the Italian space industry. The second generation of the Cosmos system will ensure the continuity in the services so far provided by the first generation satellites and ground segments, representing a real generational leap in terms of technology, performance, and operational life of the system, and providing new application possibility. Both satellites of the second generation are improved version of the original design. The Cosmos second generation SAR is also an improved version of the first generation X-band SAR system. Thales Alenia Space in Italy is the program prime contractor, therefore responsible for the development and construction for the entire Cosmos SkyMed system. Telespazio built the entire ground segment of this constellation, whilst Leonardo Electronics Division participates in the program producing state-of-the-art equipment that regulates and distributes the satellite electrical power. Thanks to the progressive growth of design and technological skills in SAR, Thales Alenia Space came into the 90s with the development of the constellation Cosmos SkyMed. The satellite platform that was used in a variety of missions such as RadarSat-2 and also in the ESA Copernicus Sentinel-1 radar satellite. Cosmo gave us also important commercial opportunity. We in fact have signed an important contract with Korean Agency for Defense and Development. And we hope to continue on this successful path with other commercial achievements in the future. Finally, let me take this